Welcome to Scale Model Workshop. So many of my projects become a test bed for experimentation. My current A26 project has certainly been no exception, because it's essentially a feasibility study. One of the things I was looking forward to trying out was a material that I've thought about using for quite a long time, and I felt it would be easier for creating aircraft fillets. In the past, I've generally used either a mixture of cyanoacrylate and acrylic resin or epoxy clay. While they've worked, they're not always convenient. There are a number of elements to a fillet, but for static models where they're not functional, we can generally get by with being mindful of just the edge points and the apex. Not all fillets are created equally, or need to be created equally. Some of the fillets are structural in nature, serving only as reinforcement or for facilitating mounting of componentry, like on a tank. Adding that detail to a model is relatively easy. In this case, there needed to be a fillet around the mounting brackets for the suspension of this M48 patent tank. The edge points were masked off with Tamiya tape, and a mixture of cyanoacrylate and acrylic resin powder was flowed around the mount. The tape is removed before the material begins to set. Surface tension and gravity take over to finish the job. When I've needed more control in placing the material, I've used epoxy clay. Epoxy clay is finer than epoxy sculpt and can be nicely worked to a smooth surface with a very small amount of water. The fillet around the A26 ventral turret's more intricate. I cut a mask for the outside edge point. Epoxy clay was worked to the final contour. It was finally finished down and then primed. The issues with epoxy clay is that on some surfaces it doesn't stick well, making it tedious to place and feather out. In addition, it has a limited shelf life, so I wind up throwing most of it away, making it sort of a wasted expense. The fillets that require extra attention are prominent aircraft fillets that have an obvious aerodynamic function. For example, this well-known fillet on the P-38 was legendary for making the aircraft flyable. Not that you have to go all aeronautical engineering crazy, but it does need to look the part. The fillet on this Hawker Tempest was created from cyanoacrylate and acrylic resin, and it took a fair amount of file work and care to get it to the proper shape. When creating aircraft fillets, the more difficult areas are the edge points. The fillet needs to blend with the surrounding surface, so sanding and filing need to be done very carefully to prevent ditching out of the areas of the fillet or beyond the fillet. This is even more difficult when the fillet material is harder than the surrounding material, which is the case with cyanoacrylate and acrylic resin or epoxy clay. For years I've wondered how drywall compound would work. I thought, after all, it's easy to sand and it sticks to everything you don't want it to stick to. But typical drywall joint compound is made to set up only through evaporation. So even when it's set, moisture makes it unstable and softens it. If you've ever used it, you know that it'll be usable for a fair amount of project time if you just keep it sealed. However, setting type compound is a plaster. Water's added to the powder, which in turn starts the process of crystallization with the liberation of heat. The result's stable and resistant to the effects of moisture. You can see on the label that it's non-shrinking. Here's an excerpt from a paper on setting type compound. Setting type joint compounds are plaster of Paris based and hardened by chemical process and evaporation rather than solely evaporation, giving an advantage in filling holes and gaps that would take many days to dry out, with shrinkage cracks if using the drying type compound. Another advantage to setting type compounds is that after curing they do not soften when wet. Thus they're better for moist environments such as bathrooms. Setting type compounds are available in times ranging from 5 to 300 minutes, and finish characteristics from tough and well bonded to soft and easy to sand. The idea that it's plaster of Paris is very appealing. For many years I've used dental stone to fill wheel wells of in-flight models that were supplied with ill-fitting doors. The doors in this Tamiya P51B were done in dental stone 15 years ago. The process took minutes, but here the stone's held in place mechanically with undercuts because the stone has no adhesive quality. However, the drywall setting compound does stick to stuff. To test it out, I used it to repair some molding on my front door. The molding was made of MDF and it wasn't sealed properly, so water got in it from underneath and pretty much took out this section marked A. I made a rubber mold of section B that I used to squeegee over the compound that I placed into the defect. After sealing with Zap CA Plus and primer, you can see the result. And this is 2 years of exterior exposure to heat, cold, sun, and fog. It seemed like a good candidate for use on the A26 project. So here's a simple example of how the material works and how I use it. It's easier if you mask off the boundaries of the fillet. The material's mixed up and applied. You can see that it has the consistency of thick whipped cream. You can tool it with a spatula, or in this case I used a piece of brass tubing. I like to give it a solid overnight to set up. The material is very easy to sand, so it's a good idea not to have wrinkles in the sandpaper. Forming the paper like this ensures that it'll lay flat against the tubing. When sanding, minimize any back and forth sawing. Use a bit of rolling action so that you don't ditch out the contour. Sand it down even with the borders of the tape. And here it is with the tape removed. Finally, go over the fillet as well as the edge with a coat of Zap CA+. A word about Zap CA. Not all cyanoacrylates are created equal, even with the Zap products. For instance, a coat of Zap-A-Gap over the hardest dental stone will frequently result in formation of cracks. For whatever reason, the Zap CA penetrates the plaster without cracking. The result's a very hard surface that's resistant to chipping. So I know this works very nicely with the Zap CA, though I have no clue of how some other products will work. In reality, fillets are rarely a consistent size from front to back like this simple demo. Here's how I handled a more realistic fillet on the A26. The fuselage mask was cut from Oracal. The wing side would be masked with fine line tape. The plaster was sanded back and feathered out. The entire area was primed and sanded. The final outline of the fillet was masked, and several coats of automotive lacquer primer were used to smooth everything out and establish the raised panel. I hope this video gives you some idea of how to handle this material for creating fillets and possibly exploring some other uses. So long for now, and I'll see you next time.